Hello everyone, myself Dr. Noor Alam from National Institute of Technology in Meghalaya. Today I am going to give some introduction on application and research problem on vertical axis wind turbine. So, in vertical axis wind turbine, at least actually having a lot of application. So, some of the application I am introducing here. Then I'll give some idea for some research problem which will be helpful to you. So you can proceed with this research problem. So this research problem till now no one has did. So you can directly take any of the problem and you can proceed for your work. So like for application you can see in off-grid application. So historically wind energy has most competitive in remote site where wind power requirement is less than 5 kilowatt. That means in remote areas we can use or for generating the power in small area or like 2-3 household we can utilize this wind turbine, small scale wind turbine generally, or vertical axis wind turbine we can apply. Here also you can see in off-grid application for charging of batteries we can use the this vertical axis wind turbine. Water pumping, these are generally used, already used. This vertical axis wind turbine can be used for water pumping in agriculture sector, for irrigation, street lighting. You can see here for street lighting, for in the banner we can use this vertical axis wind turbine. Also with the communication tower you can use this vertical axis wind turbine. And in on-grid application you can see there is this mainly you can see its applications mainly on the for large scale wind turbine, or you can say large scale wind turbine whose diameter generally 50 meter to 100 meter diameter. This type of turbine can be built with the grid, with the electricity grid. Here we have mentioned that wind energy system feeds electrical energy directly into the electric utility grid. That means that's a combination between the electrical energy which is produced like a from hydropower plant or steam power plant or any other power plant can be combined with the wind power plant. Also there is a combination of solar panel and the wind power. If this combine for charging the battery. For charging the battery, generally, I want to mean that for charging the battery, we can utilize solar energy, solar panel. We can utilize, and in combination with that means wind turbine can also be utilized. Because when solar power is not there, but the wind is mainly generally available, so both combination we can utilize the power. So next part we'll discuss about some research problem, which is you can directly work for your problem. If you are facing some problem, to choose which problem you have to work for a wind turbine. It may be vertical axis wind turbine based on the drag force, or it may be based on the leap force. You can choose any of the problem. I'll discuss how to choose the problem. Like first of all, in my study, I have developed a new blade profile. So you can go in the Google. You can search in the internet and how I have designed the new blade. So you can also create one new blade by numerical and experimental analysis. So that will be your new blade profile. So after creating a new blade profile, you can use some augmentation technique, as a lot of augmentation techniques are there. I want to mention here something like a deflector, curtain plate, nozzle shape, and a lot of others are there. So you can implement this augmentation technique with the new blade profile. There will be a lot of discussion will be there. So you can publish some good papers by implementing the augmentation technique. Also, if you search in the Google, you can also find a lot of paper which are published just utilizing the augmentation techniques on the it may be on Savonius vertical axis wind turbine. And one more thing, that is the coupling between optimization algorithm and CFD solver. This is a very new topic. You can directly choose to optimize the Savonius rotor blade profile. This is the nowadays good method. You choose optimization algorithm using the using in a MATLAB. In a MATLAB, you use the optimization algorithm in MATLAB and use CFD solver in ANSYS Blade, and you couple these two and you try to get one optimized blade profile. That's you can get two three papers only using these two methods. So it will be a good for you. Implementation of multi-objective genetic algorithm. So you can use the lot of algorithm are there, like genetic algorithms are there, like you can choose simplex search method, you can choose multi-objective genetic algorithm to optimize the various geometric and aerodynamic parameter of the Savonius vertical axis wind turbine. Next problem is in the Darrieus vertical axis wind turbine. So in Darrieus vertical axis wind turbine, problem is these are less self-starting capacity. So in order how we can improve the self-starting capacity, that maybe is one of the important topic you can study. Like generally people used to do combine Savonius and Darrieus rotor they have used, because Savonius generally it increase the self-starting capacity. So by combining this is performance generally increase, but some studies lot of studies there on self-starting capacity, but you can think some more blade vortex interaction. So in case of like Darrieus rotor, there is a vortex formation is there. So you can try to reduce this vortex formation. That will be one of the good topic in your study. And optimization method in case of as I have mentioned, then is Savonius rotor, you can use the optimization technique. Here also you can use the optimization technique to optimize the various geometric parameter and blade curvature effect. This is one of the parameter, because blade curvature is affecting the performance. So if you try to get the optimum blade curvature, that again it will be your one of the study. So offshore wind turbine. So in the moving surface mechanism, so one of the important thing is moving surface mechanism. I can say like if this type of like aerofoil, you just think that aerofoil here will use one surface, because in this side there is a flow separation will be there. So in flow separation, when there is a flow separation, this is nothing but is going to reduce the performance. So in this side, if we give some like a moving surface mechanism with the help of roller, that time it will reduce the flow separation and it will increase the overall performance and slotted flaps rotor. So these things it will be easily understandable to you. Like you have seen in aeroplane, that aeroplane wings are like various aeroplane wings or flaps. Aeroplane flaps is made with various slope. Lot of slows are there to reduce the flow separation and to increase the lift. So same mechanism you can use in case of offshore wind turbine. And another is pitching control. You can control the pitch to get the optimum performance. And hydro turbines, because nowadays Savonius rotor used as a hydro turbine for small scale power production, that can also be done. And combine Savonius Darrieus rotor, as I had mentioned. So but a lot of studies are there. You need to think which parameter you have to study and which parameter you want to optimize. And two-state elliptical bladed rotor, this is a completely new study. If you want to perform study directly, you can start this one. Two-state elliptical bladed rotor, this blade profile no one has studied. So if you think elliptical blade, you can choose based on some literature which is available. Now, finally, you can think about the closed flow hydro turbine by optimizing various geometric parameter, rotating blade shape, and the optimization algorithm. So I hope this discussion will help you. Thank you.